Okay, this video is designed to help you go over your applications of algebra test that you just completed, work out where you made some mistakes so that you can actually have a second shot at a similar test and perform much better. So I'm going to go over these questions quite quickly, but slow enough that you can actually understand perhaps how to do them. So question one on the test. So turn to your first page, question one, and we're going to go through this together. Make sure that anything that you did incorrectly, you've written down the notes that we're going to do here in this video so that you can work out where you went wrong. Okay, so our first question is question one. We've got a square where each side is 2x. So let's have a look at this. So for question one, we've got a square and each side was 2x in length. So this side's 2x and this side's 2x, 2x and 2x. Now, marking the test, the key things I saw was that a lot of people got perimeter and area confused. So the first question was we had to work out an algebraic expression for the perimeter. Now the perimeter is the distance around the outside. So start from some key point, a starting point, and you're going around the outside of the shape like this, and we just want the total distance around the outside of the shape. Now we've given no numbers here. What we're given are pronumeral expressions. So the perimeter is the distance around the outside of the shape. The distance around the outside of the shape. So it's this distance plus this distance plus this distance plus this distance. So the perimeter of our shape will simply be 2x plus 2x again plus 2x again, and then plus 2x again. So we're adding the four sides together. And so if we add those together, 2x plus 2x plus 2x plus 2x, well, these are all like terms. So we can add them together. So 2x plus 2x is 4x, plus another 2x is 6x, plus another 2x is 8x. So the total perimeter is, 8x, yeah. So the total perimeter is 8x. Not 8x to the power of 4, not 8x to the power of 2, it is simply 8x. So the area, so that's our formula for the perimeter. The area of this square is length times width. So area is equal to length multiplied by the width. Well, the length is the same as the width in this example. So it's going to equal 2x times 2x again. So we're now multiplying algebraic terms. So we multiply the numbers together. 2 times 2 is 4. And x times x is x squared. So that's where our squared is going to come in when we're multiplying x together. X times x is x squared. So that's part A, and part B of the question. Part C, we had to work out the perimeter when x equals 3. So we want to work out the perimeter when x equals 3. Well, guess what? Here's our expression for the perimeter we just worked out in part A. So to work out the perimeter when x equals 3, we just substitute x equals 3 into where we see the x. So the perimeter when x equals 3 will be 8 times 3. Remember, 8x equals 8 times x. That's 8 times 3, which is 24. On the other hand, in part D, we had to work out the area when x equals 5. Well, here's our expression for the area of the square. We want to work it out when x equals 5. So we're just going to plug x, or substitute x equals 5 into where we see the x, into the area expression. And so it'll equal 4 times 5 squared. 5 squared is 25. 4 times 25 is 100. So that will equal 100. Okay. Question 2. So go back and have a look at question 2. Question 2 was a similar sort of question, except this time it's a rectangle. So let's go and have a look at this one. So question 2. Rectangle, and the values of our rectangle were 5x, 5x and 3x. Now I reckon already you could do this, you could finish question 2 on your own now. So the strokes here mean that those two strokes here mean that these two are both the same, so that's also 5x. We had a single stroke there and a single stroke there, so they're both equal to 3x. So once again we had to work out the perimeter. Well, once again the perimeter is the distance around the outside, so we need to add all the sides up. So the perimeter will be 5x plus 3x plus 5x again plus 3x. And so that will equal, if you add those up, they're all like terms, remember, they're all x terms, so 5 plus 3 is 8, plus 5 plus 3 is 8 again, that's 16x. Just 16x, that's the perimeter of this shape. The area of the shape, A for area, is equal to, once again, the length times the width. So it's going to be 5x, that's the length, times the width. So it's going to be 5x times 3x. And if we work that out and simplify it, 5 times 3 is 15. X times x is x squared. So there's the expression for our area. So I've got two expressions now. There's the expression, algebraic expression for our area, and there's the algebraic expression for the perimeter. So in part C of the question, we have to work out the perimeter when x equals 2. Well, let's do that. So when x equals 2, so we substitute the value x equals 2 into the expression for the perimeter. So it's going to be 16 times 2, which is 32. Part D of the question, we had to work out the area when x equals 4. So we're going to substitute x equals 4 into the area expression. So this answer is going to be, that's going to be 15 times 4 squared, and 4 squared is 16, so it's going to be 15 times 16, which actually equals 240. So the answers to C and D were 32 and 240. Okay. Whoops. We don't need that. Looking at question 3, this question, once again, similar, but now it's getting a little bit more complicated because now we've got a length and a width that actually have more complex expressions. So let's go back and have a look at this one. So question 3, there's our rectangle, and our expressions are 4x plus 3 along the top, that's the length, and 2x plus 1 along the side here. And that side is the same as that side, and that side is the same as this side. So this will also be 2x plus 1, and this will also be 4x plus 3. Okay, you should be able to do the perimeter now. Pause the video, work out the expression for the perimeter, and then replay the video to, commence the video again to check your answer. Okay, welcome back. Working out the perimeter. The perimeter is going to be this length plus that length plus this length plus that length. So it's going to equal 4x plus 3 plus 2x plus 1 plus 2x plus 1 plus 4x plus 3 again plus 2x plus 1 again. So what we're now going to do, this is a bit more complicated, as you can see. So what we're now going to do, we're going to regroup. We're going to group all the x's together. And this is why you learnt these skills earlier. You need to know how to regroup to actually solve these problems. So grouping all the x terms together, and we'll highlight those. There's an x term, there's one, and there's one. So it's going to be 4x plus 2x plus 4x plus 2x again. And then we're going to group our numbers. Well, our numbers are clearly positive 3, positive 1, positive 3, and positive 1 again. And 3 plus 1 is 4, plus 3 plus 1 is 4. That's going to actually just be plus 8. Okay? So the final answer for our perimeter is going to be 4x plus 2x is 6x, plus 4x plus 2x is 6x. That's 12x plus 8. There is our expression for the perimeter of our shape. The area of the shape is going to be length times width. So it's going to be 4x plus 3 multiplied by the width, which is 2x plus 1. And here you had the option of using the square method. So we'll just do the little box over here. Remember, it's a 2 bracket. It's a 2 by 2 bracket, so we need a 2 by 2 square. So 4x plus 3, we'll write the 4x plus 3 along the top, and the 2x plus 1 we'll write down the side. So 2x plus 1. Now let's work out what goes in each of the boxes. 2 times 4 is 8. X times x is x squared. 2 times 3 is 6. And it's going to be 6x. So it's positive 6x. 4x times 1 is 4x. And 1 times 3, a few people put 4. 1 times 3 is 3. Okay? So putting all those terms together, it's going to be 8x squared plus 6x plus 4x plus 3. Now remember, these two middle terms are like terms, and so we can combine those, and that's 10x altogether. So the final answer is going to be 8x squared plus 10x plus 3. So there's our expression for the area. Okay, so we've got an expression for the perimeter, which is there, an expression for the area, which is here. Now, to work out the next part of the question, in C and D of question 3, we had to work out the perimeter and the area when x equaled a certain value. So here we had to, part C, we have to work out the perimeter if x equals 2. So the perimeter of x equals 2, which means we plug x equals 2 into our perimeter expression. We substitute x equals 2. So the perimeter will be 12 times 2 plus 8. Which is 24 plus 8, which equals 32. So that's the perimeter when x equals 2. In the last part, we have to work out the area when x equals 3. So we substitute x equals 3 into our expression for the area. Now we could plug it into this one, we could substitute into this expression, or we could substitute into this expression. It doesn't matter because they're the same expression. That equals that. Anyway, we'll use the blue one. So the area when x equals 3 is going to be 8 times x squared. So it's going to be 8 times 3 squared plus 10 times 3 plus 3. And that will equal 3 squared is 9. 9 times 8 is 72. So it's going to be 72 plus 10 times 3 is 30 plus 3 that's going to equal 30 plus 72 is 102 plus 3 is 105. So the answer to part D was 105, the area when x equals 3. Okay, moving to the next question. So now we're on to question 4. This is a little bit harder again because now we've got two expressions, but one of them has a minus in it. 3x minus 1. So let's go back and have a look at this one. So this is question 4. So our expressions are 5x plus 3, oops. So this is going to be 5x plus 3 here, and this side is 3x minus 1. So I think you might be able to do this on your own. Pause it, have a go, and then we can recommence the video when you think you've had a fair shot and want to check the answer. Okay. The perimeter of this shape is going to be 4 sides added together. Now remember, this is 5x plus 3, and this is 3x minus 1. Now we've got to be careful. We've got some minus signs in here, so we've got to watch that. So it's going to be 5x plus 3 plus 3x minus 1 plus 5x minus 3 plus 3x minus 1. So they're the 4 sides added together. And once again, we need to group our terms. So I'm going to perhaps save a bit of time and a bit of space and not go through the whole grouping process. But just remember, it's going to be 5x plus 3x plus 5x plus 3x. That's going to be 8x plus another 8x, which is 16x. So that will equal 16x. 3 minus 1 is 2. Minus 3, oops, that should be a plus 3, I think. I beg your pardon, that is plus 3. I'll try that again. So it's plus 3, minus 1 is 2, plus 3 is 5, minus 1 is 4. So 3 minus 1 plus 3 minus 1 is plus 4. So there's our expression for the perimeter. The area, that's part A. Part B, the area, once again, it's the length times the width. So that will equal the length, which is 5x plus 3, multiplied by the width, which is 3x minus 1. And once again, we can use our box method. So we set up a little box, another 2 by 2 box, like this, to multiply out those two expressions. Along the top, it's going to be 5x plus 3, so 5x plus 3, and on the sides 3x minus 1. That's minus 1. So what goes in the boxes here? 3 times 5 is 15, and x times x is x squared. 3 times 3x is 9x. That was positive 3 times 3x, it's positive 9x. Down here, 5x times negative 1. Well, 5x times 1 would be 5x. 5x times negative 1 is negative 5x. And finally, 3 times negative 1 is negative 3. So, putting all those together, the area is going to equal 15x squared, 9x, take away 5x, remember they're like terms, so we can combine them. 9x, take 5x is 4x, so it's plus 4x, and then minus 3 on the end. So, to work out part C and D, part C we had to work out the perimeter when x equals 6. Well, which of these is our perimeter expression? Yes, it's this one. That's right. So we have to work out the value of the perimeter when x equals 6. So you know what to do now. You substitute x equals 6 into the expression. So the perimeter when x equals 6 will be 16 times 6 plus 4. Now remember your order operations. You multiply first, then add last. 16 times 6 is 96 plus 4 is going to equal 100. So the perimeter around that shape, if x equals 6, is 100. On the other hand, the area, I'll go yellow. And I might just get rid of that bit there, just give me more room. So the area is going to equal, so we want the area when x equals 2. That's part D of question 4. The area when x equals 2, where we're going to substitute x equals 2 into our expression for the area. There it is there. There's our area expression. So wherever we see an x, we're going to replace it with the number, or substitute the value 2 into it. So it's going to be 15 multiplied by, not x squared, but 2 squared. So 2 squared plus 4 times 2 minus 3. And that will equal 15 times 2 squared. Well, 2 squared is 4. 2 squared is 4. And 2 squared is 2 multiplied by itself. That's 4 times 15 is 60 plus 8. 4 times 2 is 8 minus 3. So that will equal 68 minus 3, which is 65. And so your answer for part D of question 4 was 65. Okay, question 5. Oh, that was tricky. This is where we had a shape and there were 2 sides we didn't know. So let's have a look at that shape. Let's have a look at this problem. So question 5. There's our shape, and we know that, actually I'll just get rid of this bit here. Okay. So in this shape here, we know that that length along across there is 5x plus 1. And we know that this is also from here to here, 5x plus 1. This was 2x plus 1. And this was 2x. This side here and this side here, we didn't know, or we weren't given. So, before we can work out either the area or the perimeter, we need to come up with an expression for the orange and the red side. Now, the orange side is the shorter dashed line. That was the shorter of the 2 sides. And the red side is the longer of the 2 sides. Okay, so they are the 2 dashed lines. So, you might see that this distance from here to here plus from here to here is equal to 5x plus 1. So from there to there is 5x plus 1. But guess what? We know that from there to there is 2x plus 1. From there to there is 2x plus 1. So that's 2x plus 1 from here to here. So this missing bit here, this orange bit, the orange bit plus 2x plus 1 must add up to this. So this side plus that length there must add up to this. So we need to take this away from the blue side, 5x plus 1, to leave us with the orange bit. In other words, 5x plus 1, take away the 2x plus 1, will leave us with the orange bit. So the orange bit is going to equal, that's the shorter dashed line, so the short side is going to equal the long side here, 5x plus 1, take away, now because we're taking away a side, the length of the side is 2x plus 1, so I need to put that in brackets. We're taking away 2x plus 1. We're taking all of that side away from this side to give us what the orange dash line is, the shorter dash side. So let's work that out. It's going to equal 5x plus 1 minus 2x, then minus 1. Remember, everything is being subtracted, so we're minusing 1 as well. So it's going to be 5x, grouping our terms, 5x and minus 2x are the x terms, and the number terms are plus 1 and minus 1. So it's going to be 5x minus 2x plus 1 minus 1. 5x, take 2x is 3x, and 1 minus 1 cancels out completely. So that distance there is 3x. The longer side, it's the same idea. This side here, this length, plus this length equals this length. So this side plus this side equals the long side here, which means if we have the long side and we take away this bit, here, that will leave us with this bit. So the long side is going to equal this length here, the long side, 5x plus 1, and we're going to take away, once again, we're taking away a whole side, we're going to take away all of this to leave us with this. So taking away 2x. So 5x take 2x is going to be 3x. And we've got 1 just left on its own. So it's 3x plus 1. So this side here is going to be 3x plus 1. So now we can work out the perimeter, because the perimeter is going to be, starting from here, 2x plus 1 plus 3x plus 1 plus 3x plus 2x plus 5x plus 1 plus 5x plus 1 again. Now, grouping our terms, I'll highlight the terms. So we've got positive 2x, positive 3x, positive 3x, positive 2x, positive 5x, and positive 5x again. They're all like terms. 2 plus 3 is 5, plus 3 is 8, plus 2 is 10, plus 5 is 15, plus another 5 is 20. That equals 20x. Let's do the numbers in green. Plus 1 again, plus 1, plus 1. So it's going to be plus 4. So the perimeter is 20x plus 4. And we can now do the area. The area of the side is simply, well, remember we said this is rectangle A and this is rectangle B. So if we work out the area of side A and then work out the area of side B and then add those together, that will be the total area expression for the total area of this rectangle. So what will I do? I will go back to here and I'll get rid of, oops, with all of that, give some room. Okay, so the area the area of A, let's look at the area of A in here. So the area of A is going to equal its length by its width. So its length is 5x plus 1 multiplied by its width, which is 2x. Now, we can use the box method here. Now, this is a 2 by 1 box we need, because there's only one set of brackets here, so I only need a box like this. So it's 5x plus 1 across the top and 2x across the side. So 2x times 5x is 10x squared, and 2x times 1 is 2x. So the area of that box will be 10x squared, 10x squared plus 2x. Box B, which is this one in here, area of B, that will equal its length by its width. That's going to be 3x plus 1 multiplied by its width, which is 2x plus 1. And we can use the box method there to quickly finish that. And this is going to be a 2 by 2 box once again. So 3x plus 1 along the top, 2x plus 1 across the side, and filling in the gaps. 2 times 3 is 6, x times x is x squared, 2x times 1 is 2x, 3x times 1 is 3x, and 1 times 1 is 1. So it's going to equal 6x squared plus 2x plus 3x plus 1, which equals 6x squared plus 5x plus 1. Now, the total area of both rectangles is going to be the area of A plus the area of B. So it's going to be the area of A, which is this, plus the area of B, which is this. And we just need to add those together. So let's make some final room and do that. I'll just, try that again. Let's get rid of all of that. So the total area of our shape is going to be the total area, total area will equal area A plus area B, so it will equal 10x squared plus 2x plus 6x squared plus 5x plus 1. And collecting like terms, so we've got, there's an x squared term and there's another x squared term, they're like terms. 2x and positive 5x, there's two other like terms, and then we've got the number plus 1 sitting on its own. So let's group those together. So it's going to equal 10x squared plus 6x squared is 16x squared plus 2x plus 5x is 7x, and plus 1 on the end. So there is the final expression for the area of that shape. And the final question is the swimming pool question. And if we do that, let's see what we've got going on here. So we'll hide that. So here's our final question. And move that out of the way, and we'll get that out of the way, and we'll move this out of the way. So if you remember, with our swimming pool question, the length of the pool from here to here, so the length of the pool is 25 metres. So there's 25 metres in there, I might go black actually. That's 25 metres in there, and the width of our pool is 10 metres. That's 10 metres from here to here. And we know that that distance there, from there to there, is x, and that's x. That distance there is x, and so is that distance. So, an algebraic expression for the length of the pool and the path. Well, the length of the pool and the path is from here to here. That's the length of the pool plus the path. So it's going to be x plus 25. So the length of the pool and the path, which is part A, is going to equal 25 plus x, which is 25 plus 2x. The expression for the width of the pool and the path, that's going to be x plus 10 plus x again, so that will be part B, which is the width of the pool and the path, will simply be 10 plus 2x. The area of our pool, well, that's the blue, that's the water. So the area of our pool in here, pardon me, the area of the pool will equal 25 times 10, which is 250. We now want an algebraic expression for this is part D now, an algebraic expression for the area of the pool and the path. So the area of the pool and the path is this huge section in here. It's all of this, the area of the pool and the path, all of that. What's going to be the length times the width, which is going to be 25 plus 2x times 10 plus 2x. So part D of question 6, which is an algebraic expression for the area of the pool and the path, will equal 25 plus 2x times 10 plus 2x. Now, I'm not going to do the box method again, but if you do that, you find that the answer is, after collecting like terms, 250 plus 70x plus 4x squared. Finally, we have to work out an expression for the area of just the path, which is this region in here. Now that's going to be the area of the pool plus the path, this big area, take away the area of the pool. So it's going to be the big area, which is this, take away the area of the pool, which is 250. So the area of just the path, this is part E of question 6, the area of just the path only, is going to equal 250 plus 70x plus 4x squared minus the area of the pool, which is 250. So 250, take 250, cancels. So we're left with 70x plus 4x squared as the area of the path. And finally, you had to work out the area of this path when x equals 2. Well, then you just substitute x equals 2 where you see this, and your final answer, which is answer F, should be, it'll be 70 times 2 plus 4 times 2 squared. 2 squared is 4, so it'll be 4 times 4 is 16. That ends up being 156. And that's the final answer. I hope this has helped.